Welcome back. In the last section we saw that the present value was inversely related to the time period. What did you find out about the relation between the present value and the interest rate? Was it direct or inverse? Inverse, of course. As the interest rate goes up, the present value goes down, like children on a seesaw. In the last segment, we looked at how we figure the amount of a deposit if we knew the desired amount of payments. Usually, though, we know the amount of the deposit and want to figure out the amount of the regular payments. This is often what we want to know when we take our 401k balance and want to convert it to an annuity. How much can we expect to receive each year for 10 years? But there's another type of transaction that uses the exact same math, and that's the calculation of loan payments, whether it's a mortgage or a car loan. The only difference between an annuity and a loan is what side of the transaction you are on. In a loan, the bank makes the deposit and receives an annuity. The borrower makes the regular payments. When you take out a loan, each payment must cover interest, but it must also include an amount to pay off the principal. If you didn't do that, you'd never pay off your loan. But as you pay off the principal, the amount of future interest gets less. This is called amortization. Let's take a look at the spreadsheet to see how it works. Here it is. This is a loan for $7,722, which is the amount we found in the last section. What we needed to deposit to get an annuity of $1,000. But this time we are assuming that we know the amount of the loan and are trying to figure the amount of payments. We had to do a bit of trial and error here. The absolute minimum payment is the exact amount of interest. In the first year, 5% interest on $7,722 is $386. But we also want to pay the loan off in 10 years. We could guess that our principal payment in the first year should be 1/10 of the loan amount, or $772. But if we are aiming at equal annual payments, the interest in the early years are high and principal payments are lower. By trying different amounts, we find out that the first year principal payment is $614, which added to the $386 comes to a total payment of $1,000. We then reduce the principal by the $614 and start the second year with $7,108. Take a look at the fourth and fifth columns on this spreadsheet and see how the interest payment gets less each year and the principal payment increases. They always total $1,000. The interest gets less because the principal gets less, and the interest is always 5% of the principal balance. At the end of 10 years, the principal balance drops to 0. The loan is paid off. Now it's your turn to play around with the numbers. Go to the Loans tab of the Lesson 3 spreadsheet. I've provided 2 white squares for you to play with. Adjust the payment amount. What do you have to do to pay the loan off early? Then try changing the interest. What effect does that have on the payments? If you change the interest rate, you'll have to change the payments to make it pay off in exactly 10 years. It's trial and error. At least for now. In a future lesson, we'll talk about a single calculation to figure out payments. Come back when you are done.